Welcome to Math Essential Vector Calculus. Today we will discuss about parallel and perpendicular vectors. Now with the purpose we will define what are parallel and perpendicular or normal vector. Then we will learn some methods how to determine whether two vectors are parallel or perpendicular. Parallel vectors are vectors that lie along the same line either in the same direction or in opposite direction. So if we have two vectors, they are not same size, they are pointing in different directions, or this one and this one are similar direction, but this one is opposing direction, but still they are parallel. And a match check for parallel vectors is this equation. If two vectors a and b, as far as the equation a equal to kb, where k is a scalar value, then they are parallel. Instead, perpendicular vectors are vectors which meet the condition that they have right angle between them, meaning they are completely independent direction. A match check for the perpendicular vector is that a dot p will equal to 0. We need to note an important issue that in 3 dimension, two vectors are still perpendicular. For example, this one and one here, in this one is this direction and this one is this direction. They are still perpendicular to each other once this vector is normal to a plane containing this vector a. Say this is a and this is b. Now let's learn together how to determine whether two vectors are parallel or normal using the dot product test. Let's recap first the dot product. We learned that if two vectors a and b have angle alpha between them, the dot product will be calculated as a magnitude b magnitude cosine alpha test angle. If cosine alpha is equal to 0, taking cosine minus 1, then alpha is equal to 90 degrees, means the vectors are normal or perpendicular. Instead, if cosine alpha is equal to 1, then alpha will equal to 0 degree, and then the two vectors are parallel. Note that here the result can be both of negative 1, 0, or 180. This means same direction or opposite direction. The second method is the cross product test. Let's recap first the cross product. If we have again two vectors a and b with angle alpha between them, the cross product or the magnitude of cross product can be calculated as a magnitude b magnitude sine alpha. Doing the angle test, we'll find that if sine alpha is equal to 1, angle will be 90 degrees. This means they are perpendicular. But if sine alpha is equal to 0, the angle will be 0 degree and the vectors are parallel. Again here, this one can result in 1 or positive 1, and this 90 degree, and this one is 270 degree. This means that the vectors either make 90 degree like this way or 170 degree like this way. Now with the third method, component ratio test, and note that this one is all used only to test for parallel vectors. If we have two vectors a and b and they satisfy the relation a1 over b1 equal to a2 b2 equal to a3 over b3, then these two vectors are parallel. The fourth method is the unit vector test, and it is used only to test for parallel vectors. For two vectors a and b, if the relation a over magnitude a is equal to plus or minus p over magnitude b, then the two vectors are parallel. Now we are with the fifth method, the Pythagorean test, and this to test for perpendicular only. If we have two vectors a and p which satisfy the relation magnitude a plus p squared equal to magnitude a squared plus magnitude b squared, then these two vectors are perpendicular. Let's plot this graphically. This is a, this one is p, and ab actually is just the sum of them. Graphically will be like this: a plus p. We'll find that this will form a right angle triangle, and we are interested now in the magnitude instead of the direction. Apply the Pythagorean, you will have this equation here. Let's wrap up what we have learned today. Two parallel vectors have the same line in action, whether they are in the same direction or in opposite direction. Perpendicular vectors has right angle between them. And we need to know that these conditions are basic tests for alignment and independence of vectors in geometry, physics, and engineering. Thank you.